These are probability notes 11, binomial probability distributions. Today we're going to focus on graphs of binomial probability distributions and take a look at what happens when we change this value for P, the probability of success. We're going to look at 3 NBA basketball players and how well they shoot free throws. We're going to start with a member of the Charlotte Bobcats. His name is Jeremy Lin. He makes about 80% of the free throws he attempts. And let's say during a particular game he attempts 6 free throws. Now this is a binomial setting because it meets the criteria of a binomial experiment. Binomial means 2, in this case, 2 outcomes, success or failure. Either he makes the free throw or he misses it. Trials are independent, which means what happens on one shot has no effect on what happens on the next shot. We're going to assume the same probability of success for each free throw, 80% here, and we have a fixed number of trials, in this case 6. I'd like you to show the probability distribution for the number of free throws he'd make in 6 attempts. In other words, what's the probability that he makes 0 free throws, or 1, or 2, all the way up to 6? Now we're going to use the shortcut formula binom PDF NPK to quickly obtain these probabilities. So as a reminder of how this works, we're going to turn your calculator on, and to find the probability he makes 0 free throws, we're going to go to the binom PDF option. You'll find that under second, vars. We'll scroll down a little bit till we find binom PDF. Again, make sure you're using the one that says PDF, not the one that says CDF. With this command, the first number we type in is the number of attempts or the number of trials. In this case, it's 6, comma button's above the 7. The probability of success is 80%. We write that as a decimal, 0.80, comma. And for 0 successes, I'm going to type in 0 and finish it off with a set of parentheses. When we hit enter, I get this goofy value 6.4e negative 5. We're talking about scientific notation, so instead of writing 6.4e negative 5, I'm going to write 6.4 times 10 to the negative 5th power. If you're wondering what this is equal to, this would be 0.0000064. So it's a very unlikely event. What I'd like you to do is I'd like you to use the same kind of formula, find the probabilities for him making 1, 2, 3, 4, 5, or 6 free throws, graph the distribution, pause the video, and we'll see how you did in just a moment. So as we continue to look at the number of free throws he made and the probabilities of making these free throws, you'll notice for 0 free throws, very unlikely. For 1 free throw, less than a 1% chance that he only makes 1 free throw out of 6. For 2 free throws, only about a 1.5% chance that he makes only 2. Even 3 free throws, there's only an 8% chance that he only makes 3. The most likely events for Jeremy is that he either makes 4, 5, the most likely case, almost 40%, or 6. So when we graph this distribution, this is a nice way of basically explaining what the table shows, and you can definitely see that he's most likely to make 4, 5, or 6 free throws, and it's pretty unlikely he would be down here. Now we're going to take a look at 2 other basketball players next. We're going to look at Kenneth Faried and Drummond. We're going to take a look at what their probability distributions look like and their graphs as well. So following the same instructions we used for Jeremy Lin at 80%, we're going to use a similar idea for Kenneth Faried at 60% and Drummond at 40%. Fill out the diagrams here, draw the graphs, and we'll compare and contrast the graphs in just a moment. For the second example, here's NBA basketball player Kenneth Faried, who plays for the Denver Nuggets. You'll notice that for his probability distribution, for 0 free throws, it's 0.004. That's barely going to register on our histogram. But then the opportunity or the probability that he makes 1 free throw is about 0.037. Probability he makes 2 free throws is 0.138. 3 free throws is 0.276. 4 free throws is 0.311, 5 free throws is 0.187, and 6 is 0.047. And here's what the graph for Kenneth Faried looks like. Finally, Drummond is a basketball player for the Detroit Pistons. He only makes about 40% of his free throw attempts. So as you look at his probability distribution, the likelihood of him making 0 free throws is still pretty small, 0.047, about 5%. The probability of him making only 1 out of the 6 is 18.7%, 2 is 31%, 3 is 27.6%, 4 is 13.8%, 5 is 0.037, and 6 is 0.004. If those numbers kind of sound familiar, they are basically the inverse of Kenneth Faried's free throw values. So the probability of Kenneth making all 6 was 0.047. That was the probability that Andre made 0 of them. And you can kind of see these numbers go back and forth, the same values but in a different order. Now when we compare all three of these graphs from Jeremy Lin at the top down to Andre Drummond at the bottom, as P decreases from 0.8 in the first graph to 0.6 in the second graph to 0.4 in the third graph, look at some of the effects on the graph. First of all, look at the tall bars that we have on our graph. The tallest bar for Jeremy Lin was here at 5. That was the most likely occurrence. He made 80% of his free throws, so the most likely event for him in 6 free throws was for him to make 5. Kenneth Faried only made 60% of his free throws, so his most likely occurrence was to make 4 out of 6. And Andre, well, he only makes 40% of his free throws, so the most likely event for him is 2. So one thing that you should notice about your graphs is that as P decreases from 0.8 to 0.6 to 0.4, the tallest bars move from being on the right side of the graph to the center to the left side of the graph. One other point of interest is again the fact that Kenneth Faried and Andre Drummond's probability distributions are basically inverses of each other, and because of that, their histograms are reflection images of each other. And you will always get reflection images when the probabilities are complements of each other, which is sort of like saying they're kind of inverses. 60% versus 40%, these two probabilities add up to 100%, and anytime you have this relationship, you'll have graphs that are reflections of each other. For example, if we go back to Jeremy Lin's information, if he makes 80% of his free throws, we would expect to see a reflection of this graph for somebody that only makes 20% of their free throws. So if you were a 20% free throw shooter, you would make 6 of your shots. On average, you would make 0 of your shots. And that wraps up your probability notes for today on binomial probability distributions.